Hello dear learners and welcome to this new video about PLC memory. Just like a computer, the PLC has its own space memory. Memory in a PLC is the part that stores information, program, and data. In an attempt to clarify the topic, we can identify four main types of PLC memory: program memory, work memory, data memory, retentive memory, system memory. Each fulfills a specific function within the PLC program execution cycle. Program memory holds the user-developed logic, written in ladder logic or other programming languages. Work memory stores temporarily the code and data blocks while the PLC running. Its content is lost at CPU transition mode from on to off or at power failures. Data memory made up of files. Each stores a specific tag. These include inputs, outputs, bit memory, timers, counters. Retentive memory, its role consists of saving a limited amount of data in case of power failure. Thus, retentive data restarts after repair from its previous value before failure. The choice of which data to be retentive is set in the software while programming and depends on the requirements of the process. A striking example is in counting. If a counter is held retentive and a power failure occurs at a certain value of the counter keeps counting from that value on after the power is fixed, thus not reset to its initial value. System memory, it houses the PLC operating system, firmware, and configuration settings. It plays a significant role in communication with external devices such as sensors, HMI, etc. Thus, proper management of PLC memory is vital for ensuring an optimal and reliable operation of the PLC. Especially system memory, which is regarded as the heart of the PLC memory, it ensures the firmware updates, configuration of networks, and handling errors mechanisms. In a nutshell, the PLC memories work in tandem to bring about an efficient and accurate execution of the industrial process. Consequently, as automation professionals, we are supposed to think through both the technical and strategic sides of control systems. This concerns mainly the programming stage, where the programmer needs to work on optimization by the right allocation of the memory for the program data, organizing program code, reusing the data block where possible. Data type, data size, memory structure, managing and having a good grasp of the data type and size is paramount for the automation professional. As you know, the main task of the PLC is handling data according to predefined programs and system. Data in the context of PLC include inputs, outputs, status, timers, counters, numbers. These are piled up in their respective files making up the data memory. The present table shows the data types and their corresponding sizes and range of values. In fact, data type refers to the memory space the different PLC data can take up. To effectively cover the whole of today's topic, it would be appropriate to approach it from a practical perspective. Plus, data type is considered to be the core of PLC programming. The reason why only implemented in real-world applications, we will be able to have a full mastery over it. Therefore, let's consider a basic example, a motor start. We have two input start and stop push buttons and one output, the motor. In the programming software, when we define the inputs and outputs, the PLC system places them in the inputs and outputs files respectively and assigns for each its own memory address. As you know, the information and data in computer are represented by bits. A bit is the smallest measuring unit. A bit can be either 0 or 1. Then comes the byte. The byte is equal to 8 bits. Thus, PLC memory is made up of a number of bits representing the memory capacity. The byte is read from right to left from bit 0 to 7. The bit number 0 is called the least significant bit, while the bit number 7 is the most significant bit. The word is 16 bits in size and is equal to 2 bytes. The double word is 2 words combined, holds 32 bits memory size. Now, let's locate our example data in the data memory. We have 2 inputs and 1 output. As it's already mentioned, these are put in their respective files. So the inputs stand somewhere in here bearing their own addresses. Let's take the start push button address I0.0. The input is a bool data type. It can be either 0 or 1. The letter I refers to input memory file, the 0 near the letter I stands for the byte number, and the 0 near the dot is the bit number. Now, imagine we have an input of 8 bits or 1 byte, so it will have as an address IB0 for example. The I stands for input file, The B represents the size of the input, and 0 is the byte number. In case the input is a word, it will get an address IW0 meaning word number 0. Hopefully by the end of this lesson you have a broad idea about PLC memory, which is the purpose of the video. By the way, it serves as a guideline to unlock the topic. We will see how data is used throughout this course in the programming stage. Now if you find the video interesting in some way, make sure to like the video and subscribe to Step Plus.